Statisticians, welcome back to another chapter in the exciting installment of AP Statistics. In this unit, we are going to be looking at modeling distributions of data. So, without any further ado, let's dive in. We are going to, in this particular lesson, find and interpret the percentile of an individual value within a distribution of data. So, I can find and interpret the standardized score of an individual value within a distribution of data. I'll know I've got it when I can describe the effect of adding, subtracting, multiplying by, or dividing by a constant on the shape, center, and variability of a distribution of data. First up, we have some iconic basketball players throughout the history of the NBA. We have Wilt Chamberlain, who was a famous center back in the 1960s. Of course, Michael Jordan, the famed Bulls point guard from the 1990s, and of course, my favorite athlete of all time, LeBron James. At this point, I've lost track of how many teams, but I'm pretty sure it's the Cavaliers, Miami Heat, and Los Angeles Lakers. So for this video, we are going to spend some time learning some new concepts that will allow us to finally settle the age-old debate of who was the GOAT at scoring, not a literal GOAT, but the greatest of all time. In order to do that, we need to learn a little bit about a particular concept. So meet me and my friend Guy Fieri, mayor of Flavortown. So me and Guy are headed off to college, and to do so, we need to take our standardized tests. So without any data provided to you, who do you think would actually wind up winning or performing better in a face-to-face battle of standardized tests? Me or Guy Fieri? Simply take your ready utensil and show me the money. But in all seriousness, when I took the SAT, I earned an 1100 out of 1600. However, in Flavortown, USA, they don't offer the SAT. Instead, Mr. Fieri took the ACT, where he earned a 23 out of 36. Who should Flavortown University admit? We're taking you on a road rockin' trip down to Flavortown. So a very simple analysis regarding our two performances would be to compare the scores that we earned to the maximum number of points we could earn. So as you can see here, I earned approximately a 68.75% on the SAT, whereas Mr. Fieri earned a 63.8% on his ACT. Do you feel that this is a fair measure of comparison? Am I truly that superior to Guy Fieri? I mean, come on. Look at those. Look at that beautiful bald head as compared to what seems to be, I would define as Alfredo pasta. But if you do think I am superior, please press yes. But you'll come to find out that if you didn't quite feel confident in that statistical measure that I supplied you with, well done. It's not necessarily that simple. These tests use different scales and scoring systems. What do you think we could do to attain a much more valid form of comparison between the two different tests? So what I'm not asking you, or what I'm not stating is, oh, we both take the SAT, oh, we both take the ACT. How could we take my score and accurately compare it to Mr. Fieri so that we take into account all of the different variables that we unfortunately are unable to control? Now, to do that, we're going to revisit a set of data that we have grown quite fond of, our salary data. So once again, we have our salary data from Unit 1, and we are going to look at something in statistics that we call the percentile. The percentile describes the percent of data that is less than, and here's the key piece, or equal to a certain data value. Now, in order to do so, we have to look at a proportion. So when we're asked at what percentile is the person who makes a salary of 43,000, we must first identify that 43,000. So as we can see, that value is located here. And we want to look at the amount of data that lies less than or equal to So in this case, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 data values out of a respective 12. And that's going to provide us with, oops, no of, right? But if we wanted to write this more accurately, say that a person who makes a salary of $43,000 is at a percentile of 83.3%. So this person makes more than 83.3% of the employees at this particular company. Now, how does this compare to when we were looking at graphical representations of very large data sets, i.e. box plots? Well, quartile 1 is going to contain 25%. Can I change the color? Survey says yes. Very cool. The median will contain less than 50%. And last but not least, we have perfect. Quartile 3, which is going to have a percentile value of 75%, meaning that quartile 3's value, or the value associated with quartile 3, will be greater than 75% of the data. The median value of the data set will be larger than 50% of the data. And the first quartile value is greater than 25% of the data in the data set, which brings us back to me and my boy Guy. So as you can see here, these are the respective percentile ranks regarding the SAT and ACT performance from the 2019-2020 school year. What percent of people did each test taker outscore? Once again, I scored an 1100. So looking at the SAT, a score of 1100 puts me at the 53rd percentile, whereas Mr. Fieri's 23%, or sorry, not 23, his 23 out of 36 puts him at a percentile rank of 69%. So unfortunately, while I do find myself to be the much more attractive of the two options, Mr. Fieri has demonstrated an increased proclivity for academia with his performance on the ACT, and should be the first selection for admittance to Flavortown University. That's all right. Let's go Scarlet Knights. Next up, we have what we deem in the statistical world is a cumulative relative frequency. It sounds like a very intimidating long phrase, but in all actuality, it is nothing more than a graphical representation of, wait for it, percentile. It's a percentile graph. So what we've done here is we've taken the previous table on the previous slide for ACT scores and graphed the subsequent percentile ranks according to each particular ACT scores. Now looking at this particular graph, do we deem 18 to be a good ACT score? So if we locate a value of 18, here we are, and we see what percentile it responds to the 40% the 40th percentile, meaning that those individuals who earned an 18 out of 36 scored better than 40% of test takers. So it's not necessarily the greatest, it's not necessarily the worst, it's more so just okay. However, if you are applying to an elite college and want to score in the top quartile, keywords, top quartile of test takers, what score would you need? And how do you know? Take some time here to pause this video and consider that question using the data represented here in the graph and what we've learned about different distributions in Unit 1 before proceeding on to the next slide. Now, to more accurately determine who the GOAT at scoring was, we need to standardize the data that we are looking at. So we've kind of done this with percentiles, which allow us to compare data values from different contexts. But when there are much more variables at play, we need to somehow take all of the data and put it onto a level playing field. So the way we do that is through what we call a z-score, which is short for a standardized score, because it measures how many standard deviations a data point is above or below the mean. Now, the way we do this is we take our data value and we subtract it from our sample mean while dividing by the standard deviation. Using mathematical notation that is represented by x sub I, so some data value in our data set, subtracting it from the mean, which is, if you've forgotten, represented by the lowercase Greek letter mu, and then the standard deviation is represented by a lowercase sigma. Now, for Wilt, Jordan, and LeBron, for their careers, these were the respective points per game that they were able to average. Wilt and Jordan tied at 30.1, whereas LeBron had scored 27.1 points per game through the 2020 NBA season. Now, respective to their era, the average NBA player scored this many points per game. So in Wilt Chamberlain's era of 1960s, the average NBA player scored 10.8 points. In Michael Jordan's, the average NBA player averaged 8.7 points. And in LeBron's contemporary era, the average NBA player would score 8.4 points a game. So your first task is to look at this difference. Okay, what is the difference between the points that Wilt, Michael Jordan, and LeBron were able to score as compared to their era? And utilizing that data, decide who the GOAT was at scoring. However, you might be sitting there watching this video saying, that's it? That's all I got to decide who the GOAT is? We're not considering so many different aspects of their game. Who was more efficient? Who was the most clutch? Who was the one that was least injury prone? Who was the one that was most valuable to the team? These are things that we will discuss when we reconvene in class. But until then, I'd like for you to generate some other statistical areas that may be helpful in determining who was the best and finally laying this endless debate with no seemingly right answer to rest. As always, don't forget to complete your reflection and synthesis, what makes percentiles useful, and what made LeBron have a higher z-score than Wilt Chamberlain. This question is not completable until we reconvene in class, but I will see you for our enhancement opportunities.